Welcome to ARVN, Amateur Radio Video News. The program you're about to see is free to watch, courtesy of YouTube. Thanks, YouTube. But it wasn't free to make. ARVN's got a lot of money invested in video equipment like this sweet camera and that editing system back there. And it takes a lot of time to shoot and edit a program like this. So I'm asking you to make a voluntary payment, contribution, whatever you want to call it. Just stop by our website, arvn.tv, and you'll see a link to make that payment, whatever you think the program is worth to you. I guess you could say that this program is brought to you by you. So thanks for watching and enjoy the show.
Okay, the one thing that I really picked up on yesterday when Mark was talking about how he said, when he talked about the call sign to call sign contact within D-Star, again, that's what I think ham radio should be after. He pointed out how what most people do is they connect through their D-Star node stack to a conference server of fellow interested hams. And so it kind of makes a super repeater, because anybody in the world can check into that particular conference server and just hang out there, and that's like hanging out on your local repeater, but you might not have that many D-Star users. So by hanging out on this super reflector, now you get to talk to everybody. And that's where I realized, well, why aren't these why can't not we connect into these conference servers on that the D-Star people could connect into? Why not, can that node number also be a node number in All-Star, also be a node number in Echolink, also be a node number in IRLP? And that's where I'm talking to, is where everybody can conference into the same audio conversation. And this thing, I believe, is getting weak. So here's where we left off, and when I got to looking at why don't we, these things all conference together, I was talking to Jim Dixon of All-Star, and he said, well, they are. And so just last night, I Googled D-Star, ILP, and All-Star, and boom, came up with this guy's face. I believe that's VK5ZEA, and if you go to his, follow the link, and what he's saying is, we've done it. We've hooked them all together. And he's going to give a demonstration.
Today I will be demonstrating how the VE3TNK analog bridge in Canada allows three normally incompatible internet linking systems to talk together in harmony, namely D-Star, IRLP, and All-Star Link. I've got some radios set up here on the workbench, and I'll lead you through them, and then we will give it a go. Okay. We've got two handheld radios here on the workbench. This one is an ICOM IC91AD, and I've got that on the VK5REXB frequency. That's my D-Star repeater, which is also enabled with D-Extra linking. This handheld radio is another IC91AD, and it's on the All-Star Link system. I've set up a node here locally, and I'm using 2 meters, 146.45 megahertz, and I'll show you the node. Just a PC in a spin server rack mount case. The audio is through a DMK URI USB radio interface, which is this little unit right here. And for the RF side, I'm using one of my Simoco SRM 9000 radios. And this I normally would use on D-Star. And you would have seen here my one of my Satoshi DV node adapters, and the Tate radio, which I normally use with that's turned off at the moment, so as to hopefully not cause interference. And finally, up here is my old IC2350 radio, and on the VHF side, I've got that on the reverse frequency for my IRLP node, which is now over in this rack. That's the PC for it there, featured in one of my other YouTube videos. So hopefully I've got this ready to go. I've got Nick, VK3BA in Geelong in Victoria, standing by listening on X Reflector 5A. And what I'll do is I'll issue a link command on here, and hopefully it'll connect up and we'll be able to talk to Nick via D-Star. Okay.
Module is linked.
Okay, it's told me module is linked. Back to CQ, and I'll put a call out for Nick. VK3BA, VK3BA, VK5ZEA.
Australia to Canada.
VK5ZEA in Port Lincoln, South Australia. This is VK3BA in Geelong, Victoria. Go ahead, Michael. We're sending loud and clear over.
Okay, Nick, yes, I've connected up VK5REXB to the X-Reflector 5A.
Now, I stopped it because I think this thing is 24 minutes long. And he goes to every radio in this track, and he calls into, what all did he have? Echolink, All-Star, and D-Star. And he just talks between every radio to the guy in Canada, and he's showing how this stuff is all connected. And I don't think I need to play the rest of it, but you get the idea. I think everybody wants to expand their horizons, and so, you know, that's why we're here today, is how can we connect these systems together. So anyway, that's what we're trying to do, is how can we link all these systems together. And I think that, oh, notice every one of these radios, the Echolink, the Echolink, the All-Star, the IRLP are all controlled by just a DTMF radio. And I'm saying for the APRS participation, let us play too, but let us have our station list and everything else so that we don't have to do DTMF to control our access to those links. We just send, we enter the call sign or pull it out of the station list and say connect, and just let the system do it for us. And somebody ought to be able to write an engine such as the AVRS engine to do that. So let me see if I can, does anybody see my cursor? There it is. So let's move to the next one. Next slide. And so I tried to draw that here, and that is, again, everything should be able to connect to some kind of servers so that everything can talk to everything else. And the guy with the APRS radio, yeah, if I go back 2 slides, notice the problem was that the DTMF radio has no local display of who you're talking to or anything else. It's all done by voice. But the APRS radio, I'm saying, is the if people would not think of it as the APRS radio, think of it as a radio where you could put information on the front panel to the operator, and you can take information from the operator in text form and use that as your control system. That's what we're talking about here. So you can see who you're talking to, what node you're talking to, and all that kind of stuff. Otherwise, it's just words. One thing I forgot in all these pictures, and I drew it while Mark was talking, I left off WinLink. You know, WinLink is an entire system that has connectivity. And then I also showed, I believe, that I make it on this slide, ALE, and we'll have a talk on that later because they do call sign to call sign connectivity. Now, I think I put this drawing up before. I wondered why that circle was gone. That was in a different talk, and that is the A-Star gateway is just, you know, one of these vocoder dongles, the software that makes it look like a D-Star network, and yet it talks over the voice channel and does the signaling here. And that's what I wanted to do. Now, one thing I thought was interesting in Mark's talk was he was frustrated that, you know, you drive into a new area and you don't know what, unless you bring all your directories along with you, you don't know what the D-Star node is in the area. Well, duh, that's what we've been talking about on APRS is the local digipeater should be putting that information out there. It should be putting the local recommended voice repeater, the WinLink contact point, the Echolink contact point, and the D-Star repeaters. And D-Star is doing this. D-Star now puts APRS packets into the APRS IS of where all the D-Star nodes are, and they show up on the APRS map. So when you do enter a new area, you will see them if you're on the internet. Because they're taking the easy way out, and they're injecting them into the APRS IS so all the shack potatoes can see where the D-Star nodes are, but the mobile operator cannot, and that's what APRS was for. So what the local D-Star people needed to do is not just say, I'm injecting it into the internet. They need to talk to the local APRS iGate operator and say, when you see the D-Star object in your footprint area of this iGate, that iGate should automatically send that back out to RF. And, or the D-Star node should put up a TNC and a radio to beacon that. We need to get those on the air. So now here's the D-Star radio. How do I see where all those things are? Bingo, I already showed you. You just plug in a D710 control head, and now your D-Star radio has the best of both worlds, D-Star and the APRS display. And I also showed how You can take the Tiny Track 4 with its display, attach it to the D-Star radio, and now you not only have the full icon maps on the AVMAP GPS, but you also have the text, all the signaling there available to you when you drive into a new area. And as we saw, we have the YAG tracker, which can also be hooked up to the analog side of the D-Star radio, and you have all of the APRS local information available while you're also able to do D-Star. And that's all the capabilities of that. Now, I did want to bring in some of the comments then that I got from some of the other people who were not able to make it to this conference. And, you know, Pete Lovell wrote the Java APRS server, and in fact, Pete Lovell software is what the APRS IS is. The thing that ties all of APRS together on the internet is written and controlled by Pete. And so he has a lot of weight when he says something. Because one time he didn't want to do something I wanted to do, and he said, Bob, with just one line of code, I can make it so your call sign never appears on the APRS anywhere in the world. So that's when I realized that, yeah, Pete is my friend. But his point was, people that are using D-Star, a voice system, do not want to have something interrupting them and say, you have mail. Okay, good point, I agree. Unlike DTMF triggered functions, there is no D-Star or D-Star-like function on, there's no equivalence in D-Star. In other words, he doesn't have that front panel control, which is what I'm saying the APRS radio gives you. And so I'm trying to bring all these features to D-Star, and he says you can't bring them all to D-Star because all we have is a radio and this little tiny text window. We can display information, but we cannot originate stuff. And then the next one is, you're looking at trying to do 1980s BBS type system using text to speech to get these messages into voice. And I say, yeah, that's what we're trying to do. And he says, it's okay, but on a pull standpoint. And boy, did that tie in beautifully to what Jim Dixon with All-Star is working on. And where I already mentioned, he says, well, let's just make a universal voicemail system. And in all these systems, you can just tie into one place to get some voicemail. And having each, and Pete, who did the APRS IS, he corrected me, and I said, all of these other people need to be watching APRS for messages. And he says, no, you need to have one place that's watching for messages, and in these places just check to see if they've got mail. And that matched up perfectly with what Jim of the All-Star Network said. He also continued to say, there is not any common method for D-Star radios to communicate using text. Mark, the text window, you say stuff scrolls by. What is the size of that message that can scroll by?
The total length?
Yeah.
I don't remember the number offhand. I want to say it's only like, 20 character messages each time that scroll across.
Right. And what they did was that's where they stuffed in the APRS position report. No, excuse me, the GPS position reporting that stuffed into that. Okay. But once your radio has sent your GPS position information, while you continue to talk, why can't additional kinds of information as to who else is checked in and everything else be coming in on that data stream? He says nobody's going to stop their car in order to send a DTMF message. And remember, I'm saying that it's really not messages, it's signaling. And as I've showed you, it's all about, you don't stop your car. You just, in a Kenwood, you push two buttons. Whoops, well, you got to be push to talk. Two buttons, and you can send your pre-recorded call sign, and that's most of what we're talking about here. Is this a toy that will be played with for 5 minutes and then forgotten? Oh, that's what we do in ham radio. And then to use a DTMF pad to check messages, then subscribe to a central server. So again, he was saying the same idea that Jim Dixon was his first start. And so now I'm going to try to put on this slide here what Jim Dixon's first replies were, and that is, number one, the text to voice synthesizer needs to be at one central location so that it can use one text-to-speech code. It is the thing that watches for all APRS IS messages to see if there's anything for anybody who's on these other systems, and it maintains that presence. And that way, not everybody has to collect to the APRS IS. They just check here for messages. And then this is the thing I hadn't thought about, and that is when you read your message there, every other system now knows that that message has been read and doesn't try to deliver to you over every system that you check into. And you can even read it from any plain old telephone system. You know, you just dial in to get your voicemail. And so now we're back to the any device, anytime, anywhere, you can communicate with anybody on ham radio by call sign alone. At this point, I'm going to see if I'm going to stop and turn it over to John. John, I thought I had something in here from you, but you're going to say it all anyhow, about the AVRS, the Automatic Voice Relay System, which is the acronym I made up back in 2001, and it says, that's what let's call this, because it's a conglomeration of all these other systems. We need an overarching name that says AVRS, and it is the system then that tries to help you get connected to that call sign somewhere on the planet by voice. John.
Good morning. My name's John Gorkos. I'm going to talk quickly because I've got about a half hour, and then we need to give the ALE guy a little bit of time. I currently live in Cumming, Georgia. I've been involved in APRS since about 1999. I've run iGates in several states, and I'm currently the North Georgia APRS coordinator as ordained by Bob himself. The way you get that job, by the way, is you say, hey, Bob, is there a Georgia APRS coordinator? And he looks at you and he goes, there is now. So kind of similar to, oh, we're going to have it in Atlanta? Oh, crap, now I'm a volunteer. So I learned, you think being in the Army, I would have learned to keep my fool mouth shut when it comes to volunteering, but that didn't sink in. So what I'm going to talk today about is the Automatic Voice Relay System. And this is one of Bob's brainstorms that he suckered me into implementing for him, and it's actually a pretty good idea. And I think we've got a pretty good implementation of it, and I think it begins to solve some of the universal, I can contact you because I know your call sign, and your call sign is unique in this world issues. And so, well, really, transition doesn't work the way I thought it would, but that's okay. So it's again, it's part of the universal ham radio connectivity solution proposed by Bob. It exists as a single server attached to the APRS. You can only have one of these online at a time, just like you can only have a single email gateway online at a time. Otherwise, chaos begins to reign. It's a single server. It's backed by a persistent database that is updated in real time or near real time, depending on the information source. It's constantly monitoring the APRS IS stream, which is about 40 messages per second right now, decodes them, picks out the interesting ones, and updates the database. At any given time, it knows the last position of every station that's ever reported a position, and it knows whether that position had actually moved. That had changed since during the last update period. It's also pulling down Echolink and IRLP node information, which includes goodies like where the node is, what the node number is, what frequency it's on, what its PL tone is, and I think for some of them there's a range, either PHG or a range calculation for those as well. And those are all pulled in as well, and they're all used for calculations and for routing and pathing. And then it uses APRS messaging techniques to send local connection information about VoIP gateways to APRS-capable stations. And I will demonstrate that and talk about that in a second. So here's a block diagram of how the system works. We've got our AVRS server sitting up here, hooked up to a Postgres database. And everything and I'll talk about this in a sec, but it's all open source software. 90% of it's written in Java. A couple Perl scripts that are doing some pulls from these VoIP master info. And this is going to be Echolink, IRLP, Allstar, DStar, Wires, all these guys over here. And they're all making it available to me a web pool, a web services type pool, where I say, give me all your current node information. And then I get a big download, usually in XML format or comma-separated variable format, and then I parse that up and I stuff it into my database. And that database is spatially indexed, which is kind of cool. And so I can tell very quickly, if this guy down here sends me his position, I can tell with a real quick database query what's close to him. What stations are close to him, what Echolink nodes are close to him, what IRLP nodes are close to him, and so forth. And if he asks me, I can tell him. I got this guy over here too, doing the same thing. He's sending his position into the network, and these are two-way iGates. Two-way iGates, TX-capable iGates. And I will tell you that in my experience with APRS, the biggest downfall to our system right now is we don't have enough TX iGates. And the ones we do have are woefully inadequately covered and are either configured incorrectly or are stations in people's homes that require extra bandwidth to get the coverage they need. And we need to come up with a solution to that. And I've got some proposals, some stuff we've done in North Georgia that will work with that. But if you want to know how you can help APRS be better right now, today, plug your damn radio into your computer and make it a transmit iGate. It takes an ancient 386 computer, an HT hooked up to a J-pole in your attic, and you will cover a 5-mile radius and provide this two-way capability that currently is very crippled right now. And we can't even tell how crippled it is because unfortunately we don't have a way of knowing whether an iGate is a transmit-capable iGate or a receive-only iGate. There's not a bit that tells us. There's nothing that tells us. So I can't even give you a map. I can give you a map of all of our receive coverage for the entire United States. I can't give you a map of where our transmit coverage is. We have no idea how good APRS is on the internet to radio side. And I didn't mean for that to become a rant, but you got it anyways. So that's our block diagram. Let's talk about the process flow. APRS server initializes, it comes online. I have experimented with running it out of a virtual VPS, virtual private server hosted in some server farm somewhere, and it didn't work out. It would crash, they would reboot me. It was a bad VPS server to begin with. They didn't give me enough RAM to run my Java stuff in. I wasn't willing to pay more than 25 bucks a month for it. And I discovered, you know what? I have a 25 megabit per second internet connection to my house. And I have a UPS, and Comcast fails about as often as the cloud provider did or the data center provider did. So now it's all running out of my house off of a machine I've got down in my basement. Works like a champ. The spiders love to live in my servers. It's warm, it's cozy, and whatever. So anyways, so APRS server, it comes online, the AVRS server comes online, and it starts listening to all these positions. It's pulling all these positions in, everybody's 40 times a second, stuffs them in the database. Every 5 minutes or so, goes out and asks the Echo Link and the IRLP server right now. I will add All-Star as soon as I can get with the author, and he can tell me what his format is, and we can negotiate something. Same with wires, which we haven't talked about, but that's Yezu's mamma jamma. And then I'll do it with D-Star. If I can get, it's not hard. I have to negotiate with the author, or I have to figure out a web services way to pull the information I need. It's not rocket surgery. We do it all the time. So anyways, it all gets stuffed into a database. We got this database humming along. We know where everybody is. We know where all of our nodes are. And now we start listening for AVRS messages. These are text messages that are sent from a handy talkie, a D710, UI view, whatever your product is, your client is. You send a message to AVRS. You send it with a single question mark. It'll cause the AVRS server to come back to you. And first thing it'll do is ACK you. Now, if you have an advanced client that uses the advanced embedded ACK system, I'm working on that. I don't have it done yet, but it will eliminate some of that ACK traffic. This is one of Bob's proposals, like all of them are, where we can eliminate, obviously UDP is a connectionless, UI packets are a connectionless protocol, and so we have to overlay our own connection-oriented stuff on top of it. So there's an ACK that is sent as a UI packet in response to these messages that come in. What the proposal is that the Exaster guys have implemented, and I'm sure there's a couple other clients that do, but the radios don't do this, is they embed the ACK of the last message they got into whatever response message they're sending you. So pretty clever, and I'll have that in very, very quickly. But anyway, so an AVRS message with a question mark as your body of your message will tell the AVRS server to come back. It'll send you an ACK, and it will send you information on the closest VoIP station to you. It may be Echo Link, it may be IRLP, but you're going to get whatever the closest one is. Now, if you send it, and I didn't put this in my slides, but if you send it a question mark and I, it will send you the closest IRLP link. You send it a question mark and E, it will send you the closest Echo Link node. If you are insistent on using one over the other. Now, if you send it a question mark with a call sign, it will send you the ACK, as it's supposed to, and it will send you a message including the information about the closest internet-capable node to the station you're requesting information on. So I use my call sign up here, for example. This is my Jeep parked in the MARTA parking lot down in Atlanta. If I ask it about that station, it will come back and say, The closest Echolink node to him is the one probably up on top of Sweat Mountain down there. And so now if it doesn't know where I am, it'll say unknown, or if it's timed out. I think I've got a 24-hour timeout in there. So if I've not heard from a station in 24 hours, I'm not going to try and tell you where he was last, because the chances are I'm going to be wrong anyways. And we don't want to propagate incorrect information. It's a tactical knowledge system. It's not a strategic knowledge system. If I haven't heard anything from you in a certain period of time, I'm going to assume that you've gone away. So I'll just tell you that I've not heard anything about that system. And that's one of the things we'll talk about in the workshop section is what is the appropriate time limit for that? Because I don't know. I could make stuff up, but it's not how it should work. So a message to AVRS with just the call sign in the body of the message will generate a couple things. So if I send, do I have the example up here? I don't. AVRS will, well, let's say I want to talk to Bob, WB4APR-9. But all I'm going to send it as WB4APR. I'm going to send that message to AVRS, and it's going to go out and it's going to look in the database. And it says, okay, well, I got a couple WB4APRs in here. I got a -9, I got a -7, he's carrying around his D7. I got a -10 because he's got APRS droid. There's a -5 because he's got a digipeater on the house behind his hill behind his house. He's got all these SSIDs that Bob's got. How do we know which one we want to talk to? Well, we need to figure that out. And we've got some algorithms that we can talk about, but again, as part of the workshop portion of this, we need to have some consensus, and I'd like to have some input on that. So anyways, so if we know we know the position of one of his stations, and right now I'm just picking one, believe it or not. I'm actually trying to pick smart ones. I'm trying to pick -9 and -7. But so if I know the location of these two, of the station that asked for the information, the location of the station that he asked about, I'm going to find the best path VoIP solution. Again, another thing that we need to talk about. What's the algorithm for finding the best path VoIP solution? Oops, let's go back here. I don't do a lot of drawings because I'm very artistically challenged. And I think I'm going the wrong way anyways. Yeah, I went the wrong way. Cripe. I'd like to pull up my little mappy poo here so I can show you guys what I'm talking about. Here we are. And N0 LID no lid, that was my Elmer when I got my license back in 1986. Great guy, he's up in Minnesota now. Anyways, so we got let's say this is an Echolink node here and this is an Echolink node here. And we got a couple other nodes out here. What's the appropriate way to figure out? I know that he's X miles from here. I know he's X miles from here. So if he's 40 miles from this node, but this guy's only 5 miles from this node, well, is that the appropriate path? Or do I pick one where he's 25 and he's 25? How do you pick? Do I use the Echolink node? Do I use the IRLP node? Do I use a total path length of no more than 50 miles? Or do they both have to be shorter than 25? I think Echolink gives me some range information. But really, you can't tell. I know that Echolink-L nodes are probably something parked in somebody's house, hooked up to an antenna in their roof. I know Echolink-R nodes are probably at the top of a mountain. I know that all IRLP nodes have to be installed at a repeater site because they don't allow you to do what Echolink does with local nodes. So do we prefer IRLP over Echolink because the chances are it's at a higher site? How do we figure that out? And that's a question that we need to come up with an answer to. So anyway, so we get it'll look up, try and find the best link. And I've got a real stupid, simple placeholder algorithm in there that just says, pick the one with the shortest total overall path, the length from A to B plus the length from C to D. Pick the one that has the shortest overall length, and that's what we're going to use right now. Of course, they obviously have to be both part of the same network until we get this grand overall unified messaging voice system that can bridge Echolink to IRLP to D-Star and all that. Until that happens, we have to stay homogeneous within our networks. So anyway, so if we both know both their stations, they both meet the requirements for being inside of a link path, all that good stuff, we send a couple messages. We send a message to the guy that was the target saying, hey, John wants to talk to you, Bob. Please QSY to this frequency, this tone, and be prepared to receive an inbound message. Once that message gets delivered and an ACK comes back from the guy's radio, then AVRS turns around and tells the calling station, all right, John, I got an ACK from Bob's radio, said you're allowed to talk to him. He's His radio has acknowledged that you want to talk to him. Now, Bob may be at 7-Eleven getting a Slurpee and his car may be out there, but the message has made it to his radio, which is as farthest I can go, unless I force some kind of a do you want to ACK query in there, which I don't have the capability of doing right now. So now it comes back and says, now, John, you need to change to this frequency, this tone. I don't know what the IRLP access code is. There's a universal access code that is preferred, but for example, the IRLP node on the top of the mountain that I'm on down in Atlanta uses a private IRLP frequency or access code. So, but I can't tell that because IRLP doesn't tell me. So I may have just told you to go to a system that you're not authorized to use. Again, it's a problem. I don't know what the true solution is, but there's a solution. Yes, sir?
What do we have today? Well, where do you get the IRLP database from?
From the IRLP guys.
I know, but should they identify if it's a private or public station?
That is not information that they're required to give. Remember, it's a distributed type system where it's voluntary information, where as a node owner, I log into a system. If the guy doesn't ask me whether it's a private system or not, I really don't have any way of telling him.
But it's not currently collected in the IRLP database.
It's not.
Maybe that's a suggestion for them
It
to
is.
add that.
It is a suggestion to those guys. And some of these authors are much more, much more amenable to change than others. IRLP is basically distributed as a system on a disk. You have to buy their hardware in the whole 9 yards. Is he willing to force that change, especially if it's a change that affects every node, having to go do that? And I mean, we all know how fast hams adjust to change. So now both stations, I sent a message to Bob. Bob got the AVRS sent the message to Bob. Bob's radio acted. AVRS sent a message to me saying, okay, John, you're good to go. Bob knows he's supposed to QSY there because I told his radio and his radio agreed with me. Now you go ahead and QSY and make the contact. And now, if none of this is possible, AVRS will come back and say, unable. Bob's out of range. You don't have a VoIP node in range. The stars are not aligned correctly. John's Java coding sucks and I just crashed. There's a variety of things that it can tell you, but unable is the catch-all for all that. So here's some of the challenges we've kind of talked about already. SSIDs, how do we pick which button to push here? How do we pick which is the correct one? There's a couple of algorithms that we're looking at, and if you're a Java coder or you think algorithmically, this is the opportunity to really be a great help. Do we pick the one that has moved the most recently? Well, it could be a Tiny Tracker 3 that doesn't have any capability. Obviously, in your APRS position report, you either start it with an equal sign or an exclamation point, which tells me whether or not you're message capable. So there's an indicator too. SSIDs, if everybody played by Bob's rules, we would use the appropriate SSIDs. Your D7 would have it, or your D72 or your VX8 DRQ M5 would have a -7. Your D710 in your car, your D700 in the car would have a -9. Your APRS droid has -10. Your TT tracker has got -12. Play by those rules and it makes it easier for stuff like this to work. Standardization versus imposition. So here's a couple of things here. If it's moved recently, we can use that. If it has sent messages in the recent past, if we've ever seen a message come out of this thing, hey, if you can send messages, then you can receive messages. Possibly. One of the things we're doing with Tiny Trackers is for another project I'm working on called APRS Alert, which actually takes APRS messages, translates them into SMS messages. Guy's got a solar system at his cabin, and he wants to know if his battery temperature drops below a certain point because his battery electrolyte freezes. And so he needs to do something about that. And so he wants APRS Alert to track for a message that comes from a Tiny Tracker that has some information in it, which will then generate an SMS message. So just because a device can send a message doesn't mean it can receive a message. Again, it's a challenge that we have to think about. And then really what this is about reality versus theory. Radio compatibility issues. I'm going to show you something in just a second that, Bob, I think it's just going to rock you on your heels. The Yaesu radio, or the ICOM radios, Kenwood radios, and I've insulted them twice, the tune button doesn't work inside of a message.
It's on, they are well aware of it from day one, and they said, we'll implement it when you get the system. And I said, give us the
All right, I'll talk to Don Wingo tomorrow then and tell
they
him.
know it's on the list to do.
Phil and Don need to know that, because that's, or Yoshi or whatever, your firmware dude, it's on it, doggone it. But yeah, that doesn't work right now. So you can send object messages with tune in them, or with a frequency string in them, and hit the tune button, it'll work. But if I send you an actual text message from my radio to your radio, there is no tune function right now. So we got to get that. And that's a firmware update. And now we have a whole slew of radios. Some have the right firmware, some don't have the right firmware. That's painful. You know, the Yaesus don't do it at all, or do they in a message if it comes in a message?
Not in a message yet either.
Yeah. So there's issues there that prevent this from working. And it's a chicken and egg, apparently. So now that we've got our half working, they need to make their half working. Again, we need to get back with the VoIP guys and say, look, this would be great. If I knew a range circle or a PHG, if you made your operators provide this information, then we could make more intelligent routing decisions about how to link them all together. So again, but now I'm imposing changes, or I'm requesting changes that are going to affect thousands and thousands of people. It's much easier to make a change at a single server to deal with everybody else's inadequacies than it is to get everybody else to deal with what I see as an inadequacy. So again, we talk about our total path length algorithms. Did I hit the right button? Wow, that was quick, because that was a half hour, shoot. So I'm going to do a quick demo here just to show that it works, and then I'll take questions. John, do you want to have your question before the demo?
Yeah, please.
Sure.
Okay, what about the shotgun method as far as SSIDs? Send it all to all of them.
Well, that's a thought, and it's not a bad thought. And one of the things that Bob pointed out is that all the radios, if I'm running dash 9 in my truck and I'm tooling down the road, and I was using dash 7 2 hours ago at a special event station, and someone sends a message to dash 7, my dash 9 radio is going to go off. It's going to say, you've got a message, da-da-da-da-da. What it won't do is ACK the message. But I will know that, hey, someone's trying to get a hold of me. So I can still follow the instructions QSY or send them back an APRS message saying, yeah, I'm on a different radio now, but I'm good to go. So that's a question, though. Do we want to say I got 5 SSIDs? I do. I have 5 SSIDs that I run on almost a daily basis. Do I want 5 individual messages coming out because they're all going to be in the same area pretty much, right? I don't travel a whole lot. So I got 5 SS, so that means that my local TXI gate is going to have to use 5 time slots plus the ACKs from any of those things that are ACK capable. So I've just burned a minute worth of time on my, well, we'll say 20 seconds worth of time on my local APRS digipeater because somebody wants to talk to me. Is that right?
Okay, it's been a while since I've thought about APRS. If you send a message without a SSID, it lights up all the radios at that point?
It'll light up all the radios, but then only the SSID-0 will ACK. Nobody will ACK.
I know there's no ACKs. Well, okay, you need an ACK. All right.
Everything will receive it. And I think it's a good point that since you're using heuristics to figure out which is the best one to send it to the top 2.
Top 2.
And now you've doubled your probability of getting the best shot. And that won't load the network too much. But
yeah, because I can sort by percent chance or probability of...
You've got 2 of them that are above 50%.
Yeah, I can do that.
But if there's only one, then don't.
And not everybody runs multiple radios. I mean, most folks, the average ham probably has 1 SSID that they use. And we're above average hams. Yes, sir.
Can you have the T gates or the TX gates send out periodic beacons so you know how strong they are on the system?
Well, all the I gates are going to beacon anyways, right? They're going to beacon twice. They're going to beacon once on the air, and they're going to beacon once into the APRS system. But they don't tell me. If they do include PHG, that's a good point. If they include power, height, and gain, then I can assume they're transmit-capable TX stations. I think that's a valid assumption to make. But a lot of them, like my stations, and maybe I need to do this, mine just include my ARRL contact information and say it's a TXI gate. Now, I say it's a TXI gate in there, but I don't include my PHG because it's really, well, that's an interesting point. That would be I need to take a note of that.
I've never bothered learning what the QAR, QAC, QAQ codes are that an iGate puts on its traffic when it goes in the internet. Why couldn't? What do those tell us anyway?
Oh, they tell us where. They tell us from the APRS IS. The question was, what do the Q symbols mean? If you look at a, yeah, cripe, maybe I won't.
I don't understand.
If you look at APRS FI and you look at what at the incoming messages coming into a system, and I'm not sure I can even, let me see if I can pull that up real quick, because we have that technology. You'll see in the raw messages section, and this is, I was looking at this guy. This guy, I don't know who WA2 WDT is, but your car is sitting in the parking lot beeping every 2 minutes. Okay, so here's this QAR. This is what you're talking about. This is injected by the APRS system on the inbound side. It's not added by the guy that's sending the message. So this is added by APRS IS servers. So it's not something that, there would have to be some indication in the inbound message to tell the APRS IS server whether it's TX capable or not.
It's added at the server.
It's added at the server level. Yeah, QARs, there's a bunch of them. There's QAR, there's QAS, there's a bunch of these Q symbols that indicate the source of this message and whether or not this message can be trusted, and some other little doodads that Pete demonstrates on his site, or on his, he gives all those, he decodes them all for us. So anyways, so I guess I can go ahead and do this little demo and show you guys that this stuff actually does work. What I've got over here, I'm going to brag for a second here. This is a VX3R, one of the dumbest radios ever made, next to an IC2AT, which was my first and favorite radio of all time. This is a tiny track too. This is one of the smartest devices ever made. Bion has done a fantastic job with this. Obviously, they're hooked together with a little cable. Got some power going into this. And this little mamma jamma is a fully capable embedded Linux box made by a company called PC Engines out of Switzerland. They're $109 a copy, 12 bucks for the case. It's got VGA, audio in, audio out, two USB ports, 100 megabit per second Ethernet, a DB9 serial RS-232 level on the outside, a TTL level 5 volt RS-232 port on the inside, plus 2 mini PCI ports inside for Wi-Fi radios, one of which I've got hooked up as an AB radio. And it's got a 4 gig flash card in it. 256 mega RAM, runs at 500 megahertz for 100 bucks. Every ham shack should have one of these things. These are, and I'm using mine as a portable digipeater right now. I've got my Verizon 3G modem hooked into the back of it, connected to the internet. And I've got my tiny tracker and my Hooji Mama here connected to the DB9 port, and everything that goes in comes out, and anything that comes to the radio over the internet, anything that comes into this iGate that this iGate has heard, it will pass the message on through. And that's how TX iGates work, right? They maintain a list of stations that they've heard within a reasonable period of time, and if they see a message come in for it, for that station, they watch all messages coming across the internet. If they see a message that is destined for a station that they have heard directly recently, then they will pass that message through. Now what this does though, Bob, and I didn't realize this, completely screws me on objects, because I wanted to be able to send objects, and they can't. Right? You use the APRS object method, message that will put objects on the map. But you can't do third-party objects because iGates don't want to pass them through to the network. And there's probably a way to fix that. There's probably a way to fix that, but it would require changing every TX iGate.
Well, what it is, it's called item in message. And
item in message.
It's just the iGate won't pass, no, and the iGate will pass it through. The only problem is that the clients, APRS clients, are not looking for an object inside a message. But that has also been on the Yaesu and Kenwood next version software, is that when they receive a message that has an object in it, they go ahead and put it in the station list like anything else, so that you will now, we can actually push these objects out through any iGate on the planet, so you can see what we're trying to send you to see. And they're going to do it. It'll be the next version.
It always is. Okay, so we're going to hope this works. So I've got a static IP or static GPS position put into this thing. So I'm going to go ahead and fire this mamma jamma up. This thing's a fully portable iGate, it's an intelligent iGate. It's running APRX out of Finland by a great Finnish name, which escapes me at the time. But anyways, I'm SSH'd into it right now. Oh, and then right now I'm using the Wi-Fi as a access point, and I bridge it over to 3G. So it's actually a 3G hotspot too. There's all kinds of cool things you can do with that. I've done voice over IP with them, radio control, it's rotor control, they'll track satellites. That's actually what we use as a digipeater up on top. We have one of those on top of our mountain as a smart digipeater. You can use any TNC with them because you put the TNC in KISS mode and you let Linux do all the heavy lifting and thinking. And that's actually the model I'm moving towards in Georgia is I don't want any more KPC3s. I don't care what TNC you have because your TNC is going to act as a simple electrical signal to tone converter and back again. The TNC should not think. We're using 15 and 20-year-old firmware in these TNCs. If you have to change it, it's an ever-loving bear. Somebody's got to burn a new EEPROM. How many people have an EEPROM burner? You're weird. So I don't, but I can FTP a file or SFTP a file to the next generation of digipeater in 30 seconds. I can walk up to it, even if it doesn't have internet connection, I can walk up to it with a USB dongle and copy it over. So in Georgia, my plan, and I will buy these things. I've already committed $2,000 or $3,000 to this effort. I will buy a new controller board if you will let me use your old TNC and put it in KISS mode, and I will make it a smarter digipeater than it is today. And I'll actually help you get internet access, we have an excellent plan for internet access, and I'll talk about that in a minute too. But I do want to demonstrate this real quick. So I'm going to come up online. I'm going to go ahead and beacon my position. You'll see my beacon come through, I hope. There's my beacon, right? It's just AB000-7 is my beacon. So I'm going to, got cheese up here. I'm just going to hold this mamma jamma up so everybody can see. Isn't that clever? Yeah, well, all right, maybe not. Well, yeah, everybody's got to complain about something. And actually, I'm just going to send a message I've already sent because I've got so many of these darn things in here. So here's one. You see, this is a message. Oops, you don't want the light on. See that? It's a message to AVRS, and it's got a question mark in it. So I'm going to hit the menu button and tell it I want to retransmit that message. So away we go. Retransmit. 144.39. There, and I just said I got an ACK back, and it all came back already. So 442.300 megahertz, tone 107, Echolink 90911 is the node. And I can even look a little bit closer about that, and it's 7.31 miles away. So how about that? So now I know where my closest Echolink node is. Now if the radio firmware was correct, I'd hit the tune button, which doesn't exist, and it would my B side or my non-data side with that would immediately switch over to that radio. I'd be on the right tone, the right frequency, and I'd be ready to rock and roll. And I'd be able to make my voice over IP calls on that IRLP node. Now, yeah, that's really ugly. Unfortunately, I thought I was doing my presentation very early this morning, so I set up a guy down in Georgia so we could do an actual Echolink conversation. We would do the entire thing. Unfortunately, he went to church. Actually, by now he's probably at lunch. But I will demonstrate just being able to send that message to. So we're going to send a message to AVRS. I'm just going to use one of my old ones and re-edit it because you can do that. Maybe. All right, so I'm going to send a message to AVRS. Tried to have these pre-canned, and I'm just not smart enough, so bear with me. AVRS. And the guy I wanted to talk to was November 4 Alpha Charlie. That's Randall. Randall's a pretty good guy. He knows his stuff. So there, I've entered in my message. Message input to AVRS. It's N4AC. It's case insensitive, which I fixed last night because it wasn't. I haven't sent it. Now it's out the door it goes. Come on, baby. There's my message. You see it show up down here on my...
I would like to hear the message.
There. Call N4AC on 442.300, and then we could actually go back over here. Do I still have it open? Of course not. That would have been too easy. I was actually monitoring the AVRS server, but I did get a message back. Let me go look at my messages. It says call. Oops. Has my screen on it? Well, that one's got, yeah, okay, so we can just look at it right there, right? So the ACK came back. So here's some of the stuff that's going on, these DigiPeter. I lost my pointer. Yeah. Oh, now you're beaconing too. Everybody's cool. So anyways, so here's the message. Right, I got an ACK back from the iGate. There's the iGate beacon right there. See, I call myself a TX iGate. Everybody knows I can transmit. Tells me call N4AC on 442.300, tone 107, echo link node 980.911. Oh, it's supposed to tell me what node he's on. All right, I have a bug in my program. This is also supposed to include, this is supposed to be which node he's listening on. I got to put an additional piece of information in there. It tells me what node number he's at so I can make my echo link contact. But anyway, so Randall, though, and if I was on my DigiPeter down in Atlanta, you would see the message that went to Randall that said, Randall, ABØOO wants to contact you. Please QSY to 441.900. No, that's not our echo link node. Whatever our echo link is down there, 145, whatever. Please QSY to this frequency and listen for a contact from ABØOO. And boom, we're set up. It took a couple milliseconds of data communications, and now I can talk to Randall. I can talk to anybody that's got a call sign. Yes, sir?
Does it set up the IRLP?
It does not set up the IRLP because I don't know the IRLP codes. I know what they're supposed to be. I know what an open IRLP code is. But like I said, our IRLP node down in Georgia is a closed system. It has a custom code that I pay my $20 a year, and they send me a piece of paper that tells me what my codes are that I've never, ever used.
But now that we have the egg, see, now we can go back to those guys and say, all right, he knows that somebody wants to make a call. Let him go to Echolink and set up the call. And now all you have to do is tune there, and the connection's already made.
Yes. So that's, the system is there. It runs. Obviously, I've got some work to do. It's an actively developed system. All of the source code is available on SourceForge under the AVRS SourceForge repository. In addition to the AVRS code that's up there, I have a full suite of completely Java, external library, independent APRS decoders and encoders. So you set up an object saying my car is moving 25 miles an hour at 351 degrees at this altitude and this latitude and longitude, and it will build an APRS packet for you, or you feed it any of these APRS packets, and it will come back out with a Java object that you can do whatever you want to do with. So that's actually something that's been a long time coming, and we've had a couple attempts at it. If you're a Perl geek, there's the Perl APRS library does the same thing. I actually stole heavily from it, which is how open source works. I also fixed some of their bugs, and George Lucas, who has written APRS Droid, is using this code in APRS Droid, because that's how open source works, and I got a kudos in the about comment. So that concludes my AVRS discussion. I apologize that I went long. Does anybody have any questions or anything they'd like to know about? I can do more demos after this if you'd like to talk to me. Aside, my flight doesn't leave until about 3 o'clock this afternoon, so I can hang out in the lobby and drink beer. Talking real quick, though, about IP access. Kind of have just 2 minutes, Bob. IP access to the top of the mountain. We solved it with $80 Ubiquiti 5.8 gigahertz microwave dishes. They're this big. It's an embedded Linux computer with a MIMO. It's Ethernet in one end, 5.8 gig out the other end. They're $80. You get a pair of them. We have a guy down at the bottom of the mountain that's a local club member that's got a Comcast connection, and boom, we've got internet to the top of the mountain. And then we went to our local county and said, hey, look, we need a backup internet connection for the top of the mountain because we're running our D-Star over it. And once you have IP at the top of the mountain, you can give it to everybody because it's 150 megabit per second link. Now, the internet connection isn't that fast. It's only 6 megabits a second, but it's 150 megabit per second link over that wireless connection for $80 an end. We've got the D-Star guys can use it, the Echolink guys can use it. We're going to move our IRLP node to it. The tower owner has an IP camera so he can keep an eye on what's going on up there. Our auto patch, we're going to convert over to voice over IP. We're going to get one of those Magic Jack dongles, and instead of paying $70 a month for our phone line, we're going to pay $25 a year for our auto patch phone line. And we can do all of our control over it. Because I have an intelligent box at the top of the mountain, I can do all kinds of smart things with it. And when I went to the county, they said, sure, not a problem. We'll just give you a VLAN. It'll be your own private VLAN. You'll be completely segmented from all of our other traffic. And I said, well, by the way, can you give me an external IP? And they said, no, but we can port forward whatever you want. And this is without really having an association with the county at all. I mean, we walked into these guys cold and said, this is what we want to do. We want to put a dish that's about this big on the roof of the administration building, and we want to shoot it to the top of the mountain, and you will be our backup link. Our primary link will be the other side. And then we said, and oh, by the way, if you ever need it, we have 5.8 gig coverage in a 180-degree circle on top of the mountain, and we will be happy to help you if you lose comms. We can get IP out of this building in 150 megabits a second and put it anywhere within line of sight of the mountain. Range of the radios is 35 kilometers. So it was cheap. It was dirt stupid cheap to do. And that, again, that's the other thing I'm going to do with the digis in Georgia is my digis are about 25 miles apart down there. I'm going to start shooting 5.8 gig, and I'll do a mesh network between all these mamma jammas because they're all sitting on top of mountains, and every one of them will become a TXI gate, a high altitude TXI gate, and we will have, by God, the best coverage in the world. Yes, sir. The dish is made by Ubiquiti. It's UBIQUITI. Yeah. UBNT.com is the website. UBNT.com. And it's, they've got a whole range of great stuff. And it's all open source embedded Linux boxes. They give you the SDK for it. You can SSH into these things. It's got a beautiful web interface. And they're made by great, hardworking sweatshop laborers in China. And they're dirt cheap. UBNT.com. Yeah, Uniform Bravo November Tango.com. So, all right, thank you again so much for listening to me ramble up here, and I'll be available for questions afterwards.
Okay, next is Ken Heitner, because everything here, though, we talk about is tied into the internet. However, we've got HF radios, and we have automatic link establishment, and there is a way to get things from point A to point B, and it's another system that has connectivity by call sign, and it's actually independent of the internet. And so I thought that we ought to know where those people are too. Their presence should be visible to all of our systems. So Ken, if I can hook you up.
My purpose is, in talking to you this morning, is to provide a sort of a status report on automatic link establishment, which we refer to as ALE. This is still new technology for many amateurs. The key question is, how does ALE work, and how can it be integrated into automatic voice linking and digital messaging systems? It becomes a very important question for emergency communications. The question I will try to answer for you today is how to use ALE systems to support this type of emergency communications.
It's up there. I don't know what my laptop is doing.
Yeah, second slide.
Okay.
There we go. ALE lets radios in a network decide what is the best frequency for operation. ALE can provide either a voice channel link or a text data link for message traffic. From a pragmatic viewpoint, it would probably work best at a regional level of a few hundred miles. The range of frequencies involved would also support longer links. Its effectiveness will still be determined by the power levels and the types of antennas that are used. There are ALE ready radios. As a rule, they're very expensive and scarce, and they're not a practical option for amateur use. Okay.
Here, the top button here.
Top
button on there.
Okay. Next. There we go. ALE is a simple and straightforward system. Each radio in the network is scanning and listening to the same reasonable number of preset channels. At each channel, it is listening for a digitally encoded version of the call sign. Now, if all the stations in the network are silent, no information would be generated. However, if periodically, like once an hour, each station broadcasts its call sign, then there's an opportunity. The other stations in the network can hear these broadcasts, and at least on some of the channels, they record these soundings as link quality information for each channel, so they have an idea of how good the link is back to the other station. And two parameters that are really recorded are a bit error ratio and a signal to noise ratio. Okay. The central purpose of ALE is to link stations. A link is usable if it has a good signal to noise ratio as a communications channel. Links are established based on recorded link quality information in the calling radio. Right now, only in the calling radio. In the end, the ability of the ALE system to establish good link quality may still depend on the transmitter power output and the radiation characteristics of the antenna. In fact, all of us have experiences with events like solar flares, which can seriously disrupt HF communications. In that case, even a good ALE system may not work. There are several approaches to setting up for ALE. The government and military agencies can buy ALE radios. They still have to be programmed with the information about the specific ALE channels used by each network, but everything else needed for operations are there. The second approach, developed by Collins and Harris, involves external ALE controllers. These interface with and control appropriate HF radios. Programming for each network is still needed, but our focus now will switch to basically software ALE. Software ALE developers tried to tailor the software so it will work with almost any reasonable PC. In particular, ALE software is made to work with computers and sound devices that are widely available. However, not all standard ALE features are available. An upgraded computer operating system and good sound device will enable all the features and give us better system performance. Other considerations for the PC. Since your ALE system is on 24/7, you want a dedicated PC to use for that, and you probably want things like UPS and other backup power systems also for the radio, so not everybody can do that. Your ALE radio should be fully synthesized. ALE operation inherently requires very close tolerances on the radio's frequency. Otherwise, the transmitted digitally encoded tones cannot be received correctly. Link quality analysis and linking depend on correct frequency of operation. The computer-aided transceiver protocol is found in most current HF transceivers. This is important to allowing the computer to direct the transceiver to scan and sound on the preset ALE channels. Software ALE utilizes this important radio feature. The main interface between your HF transceiver and the PC running the ALE software is a sound device. The ALE software people recommend an outboard sound device. They feel outboard sound devices are less likely to pick up interference and noise by devices that are inside your PC, which radiate a lot of junk. PCI sound cards are probably also acceptable. I use those. Cabling for these interfaces will vary with what radio you have, and you may be able to find suitable commercial cable, or you wind up wiring up all this stuff yourself. Software ALE could be used in many different networks. For regional HF networks, high radiation angle antennas would be the appropriate thing to use. For long-distance networks, low radiation angle antennas are more appropriate. Clearly, at a systems level, software ALE could support various types of operation. This would involve controls for antenna switching and antenna tuning. At this time, these are mainly planned development activities for ALE software, or they're a small assortment of pieces of hardware that are compatible with the current software that you can use. Some of the specific details have been worked out for specific types of equipment that can switch between or tune up antennas. More work needs to be done here. For now, it's up to the operator to deal with these issues. There are a number of companies, however, that now offer broadband antennas, B&W Classic and some other guys. ALE software is available to all for downloading. All the supporting technical documentation is available on the website, hflink.com. If you're interested, you can dig right into it. The documentation is very good and thorough. You just have to go through it very carefully when you set up your software package. I agree with the authors. Read everything first before proceeding. Don't expect everything to work the first time out of the box. This is more of a challenge. To be useful, network ALE stations really have to be there most of the time. ALE operations have to be dedicated. You're dedicating a certain amount of equipment to this, but you can't use it too often for other things. Otherwise, the system isn't available when it needs to be. Oops, stop button. Okay. ALE requires frequency resources for each network. The current amateur efforts under HF Link are basically all one network. That's reasonable for now. In the future, it may make more sense for these networks to be on a regional basis. Some stations could only be part of the regional network. Other stations would serve to link regional networks on a national or global scale. And then when you talk about integration with VHF and UHF networks, would also depend on how much local versus long distance linking is needed by the system. Whoops, I went too fast. Downstream, things could be different. Remember, with all these systems, when the chips are down, so is the internet. Especially when you're talking about emergency communications. Okay, last slide. Now we come to the hard facts of life. We're sort of in a new deployment mode. More stations are needed. This is a map that, well, oh, here it is. Whoops, back. This is a map that shows stations in the North American continent. We don't have anybody in South America. Here's a few people in Australia and China. Here's a few people in Europe. We need a lot more stations if you're going to have a global network. It's not a completely plug-and-play exercise unless you have the capability and the resources to buy a whole new radio and PC setup so you can run ALE. Hopefully, many people will find their existing equipment could do the job. But then there's a question of working yourself up the learning curve and participating in this particular mode for emergency use. So this is sort of a very rough idea of where we are now, but we still have a long way to go. So I'll take questions. I think we have about 2 minutes left. That was not my intent, was to cut you off, but Bob says we have to leave the room at 12. So I'll stick around for a little while afterwards to answer questions as needed. Did I lose everybody?
No. I'm going to go. Let me just see what, I think the thing that caught my eye was hflink.com.
That's a really good website.
Okay, because on this webpage, just like Echolink, just like all the other systems we've been talking about today,
I want an excuse to go to the land.
because they're running ALE using. Oh, excuse me. Because a lot of their systems are using the, download the free software, hook it up to your radio, and you're on the air. That means those PCs are also tied into the internet while the internet is up, and so they can maintain, for AVRS engine, for example, a database of everybody that's on the line right now. Their presence is known, and so that's another system that I think AVRS will know about. And if you want to talk to somebody and he's on, ALE, then you ask AVRS and it'll tell you. You can contact him on this frequency. Well, no. Again, you just go to Echolink, and Echolink should be tied into ALE, and he connects to the node, and they talk to each other. So is there a spot on this web page that shows currently active? Yeah, let me see if I can find it. I'll let him play with that. Any other questions then while we wrap up? Oh, okay, Steve's in here, so we are going to get kicked out, I guess. He's got the big hammer. But I hope that's what we wanted to show you, was that we have all these systems. They are all easy to talk to if we can just get the authors to kind of open their eyes up to realize that they could easily connect together And just a little bit of handshaking in between and some independent authors. John has stepped forward, and I'm very impressed with what he's done. Oh, by the way, his demo was in this room, but you can be anywhere on the planet and send AVRS question mark, and it's going to. Now, is it running at home also, or is it?
I was running at home. No, I was just using this as a gateway to the home.
Okay, there's the current signal quality and bit error rate on these stations right now, or I guess here's the time. This is within the last, looks like 10 minutes. So we have presence information on all these guys as well. Let's get all that stuff tied together. Any final comments? Anybody still awake?